we're bonded. That's not how this works. Welcome to the Science Asylum. I am Nick Lucid. In a previous video, I talked about how bonds don't really have energy. These bars are only here to keep this model in one piece. They're not physical things. I usually use space-filling models, which represent reality a little better. Atoms are solid balls? Alright, so maybe it's still not the best visual. Let's start with what you usually hear in chemistry class. Atoms are made of protons and neutrons in a compact nucleus surrounded by a cloud of tiny electrons. Chemistry is mostly about electrons. Bonds happen when the electrons, let's just demonstrate with some clones. Two atoms could share electrons, forming a covalent bond. Or one atom could steal an electron from the other, forming an ionic bond. Oh, that's not so bad. Yeah, except that's a bit idealized. Electrons are quantum particles, so they do all sorts of weird things. Like not moving around, or not really existing anywhere in particular. So they don't really exist? Oh, they exist, just not usually anywhere in particular. We're getting off topic. Let's take a closer look at that covalent bond in the O2 molecule. You're probably picturing some electrons orbiting in single atoms, and a few orbiting both atoms, creating the covalent bond. This isn't really accurate. It's better to imagine electrons appearing and disappearing randomly. Most of the electrons spend all of their time on a single atom, but a few of them have an equal chance of being on either. So an ionic bond is when they spend all of their time on the other atom? No, well, that's not entirely true either. There's no clear line you can draw between types of bonds. Some are just more covalent and others are just more ionic. It comes down to something we call electronegativity, which measures how well an atom can attract electrons. The scale that's usually used was proposed by Linus Pauling in 1932. Rather than use physical numbers like bond energies, a value of 4 is assigned to fluorine, the most electronegative atom, and then the rest are just scaled relative to that upper limit. To figure out what kind of bond two atoms will form, you just subtract their electronegativities. Anything less than 0.4 and you get a normal covalent bond. Anything more than 1.7 and it's considered ionic. But weird stuff happens between 0.4 and 1.7. The bond is still technically covalent because they're playing nice. But one atom is clearly holding on more than the other, and that makes him a little more negative, leaving the other guy a little more positive. Which is why we call these types of bonds polar covalent. The molecule's a bit polarized, meaning that even though it's neutral, the charge isn't spread evenly. So wait, what happens if the difference is exactly 1.7? And now we see the problem with categories. The examples I chose were obvious ones. There are some not so obvious ones. Barium sulfide is 1.69, which is under 1.7. So you'd think it was covalent, but it's not. It's considered ionic. You might think at that point that electronegativities are just a little bit off. Which is true. I mean, they're only meant to be guidelines. But that whole argument ignores the bigger issue here. Perfectly covalent bonds exist. Perfectly ionic bonds do not. All you need for a perfectly balanced covalent bond is a difference of 0. Something easily attainable if the atoms are the same. The 0.4 transition to polar covalence is pretty arbitrary. Technically anything above 0 is a little polarized. The 1.7 transition to ionic bonds isn't all that special either. The electrons are just spending twice as much time on the thief atom. To get a perfect ionic bond, you need a difference of infinity. Which is impossible! No, seriously, it's impossible. Whether it's food, cars, school subjects, or people, we seem to have trouble understanding the world around us without assigning characteristics to whole groups. No. Yes, we all know about how everyone assumed you were dangerous when you crash landed. My point is, physical reality doesn't have categories. It's full of spectrums that we force categories onto. Types of light, phases of matter, or even types of bonds. But a bond is just an attraction that keeps atoms nearby each other, just like these magnets or the Earth and the Moon. However we categorize that, the universe is going to laugh at us. So if categories ever gotten you into trouble, please share in the comments. Also, thanks for liking, sharing, and subscribing, and until next time, remember, it's okay to be a little crazy. My whole life is a lie. Good thing you're only a day old then.